All right. Can you hear me well? Hello. Perfect. Good evening, everybody. Welcome to my talk about F Sharp, serverless, and its usage in nautical transportation. My name is Provazník. I work in a company called CN Group, which is the Czech company, actually with Danish roots. Work there as a principal technical lead for .NET. If you ever heard about my name, it's because I'm the founder of Czech F-sharp community called F-sharping. I'm occasional speaker, F-sharp evangelist, and really big fan of F-sharp and functional programming in real life. Before we start, I need to share one weird experience I had with Oslo. I don't know if you see it. This is my hotel room, and on the top right, there's for some reason there's a sheep's head with glasses on the wall. And yesterday, frankly, I spent whole day thinking about two things. First of all, why would someone put like sheep's head on the wall with glasses? And secondly, does the sheep body continue to the next room? Like, how does the decoration look from the other side? I mean, I was probably the lucky one that I got it from the front, but yeah. All right, let's rather talk. Let's talk about F-sharp and nautical transportation. Let me tell you a story. The story is about, it all starts with our customer, who is called Standalone. I don't know if you're probably from this part of the world, so you probably heard the name. It's one of the largest ferry operator in the world. It was founded in 1962, and it operates in North Sea, Baltic Sea, and so on. So if you look at the map about the roads, they operate on 17 roads with total of 25,000 sailings, and their fleet size is about 37 vessels. And when I say vessel, those vessels are really, really huge. First of all, don't say boat. They don't like it. It's vessel or ship, but if you say boat, they will like beat you. So these vessels are really, really huge. For example, look at this. This is Stena Germanica. It has 1,300 passengers, 300 cars. It's massive beast. I've been there. I watched that like in person, and it's really, really huge. So Stena decided that they want to introduce some AI assistant, something to really reduce the non-trivial amount of CO2 emissions, because these beasts are really huge and producing a lot of these emissions. So Standalone decided to create something they call Fuel Pilot. To explain what the Fuel Pilot is, Fuel Pilot is a software that is running on the vessel itself, on the officer's bridge, and it combines nautical data, weather data sources, road timetables, and also there are many chips and sensors on the vessel, so it also take those. And once the vessel leaves the port, then it takes over the control and go over the sea and tries to really like do it smart way. This is not a new concept. Like, it has been done on the sea for ages, that sailors are trying to use the weather for their own good. This is actually something with the AI on the board. And when I said weather data, to be fully functional, the Fuel Pilot really needs forecast providers or forecast data. And those data are gathered from the forecast providers. We start with 4 of those. It's Copernicus, Finnish Meteorological Institute, Norwegian one, and the Danish one. And initially, before me and my F-sharp team jump into this project, it was in a way that each vessel had own instance of Fuel Pilot and own instance of some, let's say, service that was calling the forecast providers on their own separately and use the data. There was a big problem with, first of all, I don't know if you ever been on vessel on the sea trying to get to your Facebook and Twitter, stuff like that. The satellite connection is not really good, and it's sort of slow and expensive. So the problem was it was missing some kind of like central point of intelligence, central point to really gather the forecast data. So this is where the Stena Weather Service was born. This is where our story actually begins. This is where my F-sharp team from CN Group jumped in and created something which was now a unified cloud-based way how to aggregate forecasts, how to doing some advanced calculation. I will get to it later. And it behaves something like single point of truth and also handling the errors and stuff like that. To give you deep look how it really works, I have something which I call dramatic version. And this is the connection between the vessel and the weather service, right? So prepare. So it starts, what's up, bro? And the weather service say, what's up? I say it was dramatic. Look, I want to go from Kiel to Gothenburg and need the wind at 10 meters, which is one of the forecast parameters, and the wave forecast. Sailing starts at 10 a.m., and I will use this timetable, and I will use this GPS position. And you, dear Standalone weather service, please find the best providers, find the best weather forecast you can. And the weather service says, sure, bro, here's your token ABC123XYZ, and some already cached values, but ask me later for update, right, when you need it. Meanwhile, I'm going to ask my providers about the newer forecast. So this is how it all starts. You get some cached values, and after some time, for example, when the vessel is on the road for, I don't know, for half an hour, vessel asks for update. Again, like, hey, bro, yeah. Any update on my forecast for my sailing since the token ABC123XYZ was created? And the weather service says, yep, here are some fresh values. And to save you some payload and some money, I'm just sending you the diff, so we can save some of the satellite payload. And by the way, here's your new token, which is CDE45XYZ, whatever. So next time you ask me with this one, okay? Oh, thank you. You F Sharp people just rock. 400 bet requests. What? I'm just kidding. All right, so that was really dramatical version of how it works. But I would say that there's no really benefit for you in this. So I will give you a little bit more technical version, and then we will get deeper and deeper. So technically, how does it work? Is when the weather service is asked for the forecast, it checks which forecast providers covers which part of the road. So imagine the road like going from one point to another on the map, and each of those parts can be covered by different forecast providers, or they can overlap. So they checked which one is correct. Then it checks if there's any new forecast available. In other words, it checks who should we ask for the data on the road, and is it even necessary to do so. Then there are created some kind of like bulk requests, and weather a service asks if in parallel each provider for the part of the route. So for example, in here, give me wind and 10 meters for the Danish Meteorological Institute. To the Copernicus, it asks for different part of the road, different time. And for Norwegian, it asks again for the different part. Probably also can ask for different parameters, because you will see later it's not only about wind and 10 meters. And sometimes providers respond back, and data are stored in the NoSQL database in an immutable way. Why in immutable way? I will get to it later, but just keep in our heads that immutable is a good way. And when a vessel asks for the forecast, again, weather service looks for the data in NoSQL database, trimming off already past waypoints, because there is no point really to give you forecasts for the time on the road where you already gone. Like, it's nice, but who cares? We are just saving the payload. And compares the data from the previous forecast. So in case that diff is just the same, it means that there's no diff. It just sends 204, no content, just ask me later, but this time nothing new. Sometimes, unfortunately, there are holes in the data where, for example, close to the coast, there are missing values about the current or about the waves. So we do something like interpolating missing values. For the wind and current, we are using vector one. For the scalar interpolations for the waves. And interpolation happens in both like in time and in space. Of course, there are some limitations. For example, you don't want to get wave forecast if the location is on charge. You just need to like stop calculating further. But good thing is that finally, Finally, we heard it all the time that F# is for math stuff. So finally, this is the thing that we can do at least some mathematical stuff in there. Don't ask me further about this interpolation because it has been done by my colleague, and I just wrote some tests to realize that it's working. But how? How's the calculation done? Sorry, I have no idea. I'm the living proof that F# is not for mathematical people. But overall, it works well. And Standalone decided to add more and more and more. So this is not that I'm flexing here, really not. I'm just happy about it. And constantly we are connecting more and more vessels into, like from the fleet into the system. So actually, Standalone wants to apply the same success on their fleet and so on. So this is like initial part of this talk to understand what are we doing, how it went, and for you actually it becoming even now it's the part that where you should take something really impractical out of this. I am the guy who, whenever give some talk, I want to find something practical here. So I will be really giving you things that I wish I knew 2 years ago. So we will go all over the stuff. We will go from tech stack and domain modeling and error handling and background jobs. Like I will be really careful. I will be careful more than COVID-19. So I really give you everything I have. And really the goal of this talk is to give you the information to tell you what work and what not. So maybe after this talk you will be able to create your very own weather service. Or at least you will not repeat our mistakes. So if you want to start and create your own weather service in F#, first of all, you need to choose your tech stack. And of course, I'm the F# guy, so don't expect me to do it in anything else. For us, the main language was F# with .NET Core 3.1, which we recently migrated to .NET 6, of course. As an infrastructure, we decided to use Azure because we have a good experience with it. Those guys from AWS on the booth, they told me that do not mention Azure many times. I said, oh, I have to, sorry. But yeah, I personally like Azure. For the API, we use typically ASP.NET, but also with the Giraffe as a wrapper for nicely functional paradigms, for nicely functional writing. And for background processing, Azure Functions, Upservice for containers. For the storage, we really grip everything that was possible that made sense for the time. So we have a Cosmos DB, table storage, and the others. So step one, if you want to create your own weather service, is domain modeling. And this is, I don't know if you visited the talk about the DNA and about this biological stuff that I really could not understand at all, but it was really, really cool talk. I think it was Jimmy Dixon who did that. Where really F# shines is domain modeling. First of all, the type safety, the union types. I'm pretty sure if you ever saw any F# talk, like this is for you totally, you know it. You know that we have a union types called discriminated unions, that we have a records. For example, you can see here that we are not consistent in the code convention. So sometimes we have brackets here, but this is how it is. So for modeling the weather type, it's amazing stuff, and it's really, really safe. Frankly speaking, we did not use unit of measures, which is a specific feature of the F#, which, looking back, I would definitely involve them. Like, we survived without them, no problem. It just works, that's okay. There are not so many transformations between different units of measures, but overall they are like adding another layer of the safety. So I really, really, if you start over, like also think about using unit of measures instead of like you see here is the comment like degrees, meters, seconds. Like it's good. Like code is, at least some comment is better than none, but still. But really, F# overall is extremely good for domain modeling and, for example, option types instead of null. You already know that. One good thing is that if you name modules as a types, you have nice like OOP feeling. Could be also good for example, if you have a C# people in your team and you want to get them into F#, you can put some functions into the model which is named as the same as a type, and they will use the dot and they will have those functions that are related to the type itself. So it's really cool. Only thing I would say that those universal functions should be part of the domains whenever everything else which is using this type, but it's not related in the domain itself to the type, should go as an extension somewhere else. I can spend hours talking about domain modeling, but I will also recommend you on this topic one amazing or two amazing blog posts from James Randall, who's really famous guy from the F# community, who wrote Wolfenstein 3D in F#. And it's so hilarious because when he did that and model all his game, then he decided to do the very same stuff in the C# in the Blazor, like no problem with that. But it's so great when you see how desperate he is when he cannot model the domain because there's no union types in C#. I really wish they will add it in long term. So you can really feel his pain, how he cannot express himself, and it's really, really good. So go for this two blog posts. They are really informative, really nice, and also you will see if you never get into the F# before, you will see the same thing written twice, and you will understand why we are so zealotic sometimes about F#. So all right, so we have a nice domain. Everything as it should be, perfect. So now we should get some data from forecast providers, right? Okay, so first of all, forecast providers are having more APIs. First one I would say is typical REST API. I will skip most of the parts because like you already know it, but there are also another, let's say, type of the API, which is NetCDF. It's NetCDF files, and I will get to it later. Just for you, there's really like nothing mega interesting in here, except you can see the beauty of the functional composition in F#. So it's like really charming that I can put a URI definition with pass and query param and 4 points and I just plug it together like nice Lego. I like this, but otherwise, like I would think it would offend you, some advanced audience like NDC Oslo with like talking about REST. So let's skip it to the NetCDF files, which, for example, if you go to the Copernicus service, you need to deal with. And yeah, comparing to REST, NetCDF is a different beast. It was originally developed by NASA, and then you know it's going to be fun. If there's NASA involved, then you know it will be a big fun. And somehow it became the community standard way of sharing data between scientists and other strange people. So you need to deal with them. And if you look inside, it's really, really interesting stuff. You look inside the NetCDF files, data are stored in something which is called variables. And those variables are actually like matrices. And those matrices can be sliced by another variables. And whole design just follows single principle, which is store as much data as possible in the most smart way. So this is really cool stuff. I would say that, for example, our data sets are dealing with from tens to hundreds of megabytes per one file, and we need many of those. And there are so many information in it. For example, if you look inside, I'm sorry if you cannot see it properly. I'll show you later also the program you can use and jump in. And looking at each variables, you see what kind of information are there. That, for example, there's spectral signification wave height and spectral primary swell and stuff like that. And also each variable has kind of metadata information, for example, fill value, which is nothing else, just a smart way how to say there are no data in there. Name, units, validity, and stuff like that. So this is really, really, really interesting stuff. And if you look inside the single variable, jump in, you will see there are more and more things inside. First of all, for our purpose, for reading those kind of forecast data, there are latitude and longitude as an axis. There are the variables, there are the slice. So you can see that, for example, there's slice 9 out of 12. So you can slice it by time and like jump into the different version. It creates like kind of cube of the data. And there are those data holes, which means that for some GPS coordinates, it doesn't make sense to provide any value, or value is just not there. And finally, sometimes there's single value that we need to read. If you want to look at those files, let's say have some nice graphical overview, you can see it in software which is called Panoply Viewer. Again, you can download it on the nasa.gov somewhere. You can Google it. It's pretty cool. Java-based viewer. You can do a lot of stuff in that. But if you like, we can read it like that for us to have some fun, right? But for the weather service, we need to really read them in a programmatic way. And if you look on the NDC, NetCDF, no, not NDC files, NetCDF files, of course, the support, there's many languages like C, C++, Java, Python, Perl, Ruby, whatever. But looking at that, you say, hey, dude, where's my .NET? Where's my .NET library for that? And then actually you realize that we, as a .NET community, in this kind of area, we are kind of screwed because Python, if I Google NetCDF and Python, I will get like hundreds of libraries. I can decide which one is better, which one I like, who's my most favorite contributor. In .NET, you have one guy. Luckily, at least there's one guy whose name is Vasily Lutsarev, who wrote probably the only existing .NET library for NetCDF files, which is called SDS Lite. And thanks to this library, we are really able to get into the NetCDF files in a nice programmatic way, read some kind of data. We created own F# wrapper to tackle stuff like scale factor, out of set, missing values. It took us only 168 lines of code, but thanks to that, we can really nicely and easily read the data out of the data set. And I will show you that I'm not really joking. So can you see it? I'm sorry, I cannot make it bigger because it's not allowed in this in this software. So you see here are the variables, and if I create this kind of stuff, I can zoom in somehow. You see. And here are also the data and latitude, longitude. Here are some data. Finally, I can make it a little bit like get more information. Also, I can show instead of latitude and longitude, I can show the indexes of it. And I said there's a nice library there is, which is the SDS Lite, and I will show you really quick way how to read these kind of data. This is really not production code, but just for you to at least understand how thanks God to this library can at least read the file. So you see, I'm opening the science data. I have some fancy function for printing the dimensions. I'm opening the data set and just want to list the variables and print information about it, so you will see on your own. And then I said that I want this kind of variable, and because I know that this is a type of this is like 3-dimensional array with a type of single, I can read the empty value and the sum value. I will just run it. You see I'm using Rider. This is because they gave me a t-shirt today. And no, I'm just kidding, I love them. And so here you can see that I can read the metadata about the variables. I know that there's a 3D, time, latitude, longitude, and also the empty value. This is the value I was talking about, how to express that there's nothing there. And also there is some value, 652036 for index 310. So if I will go back to my code, so it to Panoply, it's 300, index 10, 652036. Okay, so it's there. So you see, really easily you can read. Thanks God for this library. So you can read the data. Probably you noticed that we are only reading one portion of the data. We are only reading on one X, and then we need to also read another direction. So this is again some stuff that's written by my dear colleague, who just knows that we need to read the information from two variables, put it together as we call it 2D, vector 2D, and transform it to the size of the vector and to the direction, because we need to know which way and how fast, for example, the wind is blowing. So that's actually it. So, perfect. We have weather data, we have a nice domain, everything is prepared. So, where should we put our data in? Where should we store them? For many reasons, we choose Cosmos DB, which is, I would say, one of the most powerful NoSQL databases ever, especially on Azure. This is really, really cool stuff. It has various levels of consistency. You can go from the strong one to the eventual based on what kind of application you are writing and what problems you are dealing with. It's really, really fast. That is important for us. It's really, really fast with the great availability. It never fell down for us. We had failures on different parts, but not on Cosmos DB. But there's one warning here, please. Be careful. Cosmos DB is expensive as hell. Can be expensive as hell. Really. You pay for the power, you pay for the request units, you need to tweak it nice to really, to be you need, like everything in cloud, you need to be smart about it because otherwise you will burning a lot of money. If you remember, I said that we provide data to the vessels as a diff. So it means that whenever there's new forecast coming, we just store it in an immutable, we just store it as an information, and later on, we just calculate the state, but we never, ever mutate anything because of, we don't like mutations, right, in functional programming, but especially because of it's fast, it's reliable, and especially in weather forecasts, the state is always wrong, so you don't have to bother anyway. Just store it, and if you are thinking, but what about my database? It will grow forever, right? Luckily not, thanks to the functionality which is called time to live, which is available for Cosmos DB. You don't have to bother with manual deletion. You just set the TTL manually on custom property on the record itself, or just for the whole collection. And when your Cosmos DB instance goes to idle, sleeps because nothing is happening right now, it takes the let's say, paid request units you have there to clean the stuff out. So this is really nice way. You just set up the data retention and you don't care about it. So you can combine smart, immutable way with this kind of automatical cleanup. For some specific areas, we also use the table storage. If you ever heard about it, it's part of storage account. It's again, amazingly cheap stuff, but there are some limits, don't even think about accessing the data without partition key, arrow key, you will end forever. But to give you more about it, I recommend to watch talks, for example, from Troy Hunt, who is using this kind of database for powering haveibeenpwned.com, his service, and it's pretty cool, and it's fast, and it costs him, I don't know, $10 a week, a month, or something like that. We just use it for some parts. All right. So we have a data storage and we have a data domain, everything. So we just serialize the data. We can go home, right? No, unfortunately. I'm really sorry about that. But this is the part where it really pains me a lot because we did that really wrong, and it still haunts me in dreams, especially nightmares. Please don't ever serialize union types. I'm an F# guy. I love union types. They are amazing. I know in these days, newtons of JSON, sysintax JSON, whatever any serializer you use can store it nicely. But you need to think about the fact that you will read it one day in some query. Especially in Cosmos DB, if you store it as a JSON, there are some SQL dialect available with fortunately, some functions that you can use. But really, don't do it. Think about the future. Think about that you will read the data one way, one day in totally different way. So just forget on the IO level, on the database level, that union types ever exist. Otherwise, you will end up with this kind of ugly syntax where is object functions is used to find out if there are any wind 10 meters data. Instead of serializing as they are, use special property to find out which union case it is. Involve it, do it really manually. Don't be afraid of manual work. Be rather declarative. and really benefit from nice syntax, and later on you will thank yourself. Trust me. Um, Again, on this topic, I really like this tweet from Einar W. Host, who said, "I hate configuring JSON serializers," and really this part is painful for me. I need to again admit that we did this wrong. We have a just configuration for serializers. We have 496 lines of code. This is way too much for simple stuff like converting some data into some different data sheet from F# types to JSON. It's way too much. I will really tell you or tell myself 2 years ago, be explicit about conversion. Just write small functions that will do it on your own. I know it's so nicely to say, for example, okay, data and zone handling, everything transferred to UTC. But like when you set it up and forget about it, it will bite you back in the time. So please avoid the magic. And again, I totally recommend. There's really nice articles from Einar about the serialization, about how actually this stuff is quite complex. I would say we could have 60 minutes talks about serialization and how it's never done in a good way. So definitely, like, please avoid the magic. All right. We slightly touch it, but let's talk more about how we actually get the data. You know that we are able to read them, we are able to store them, hopefully nicely serialize them. But let's talk about the background jobs and how we really did it. And this is also the part where we will finally get to the clickbait title with the Azure Functions, right? For background jobs, we use two kind of services. First one was UpService for containers, which is just another way how you will combine UpService and the Docker. And the second one are those famous Azure Functions. The reason why we start to combine them was rather practical, because I said we use NetCDF files, but we are also using files which are called grip2, and we need to convert them from grip2 to NetCDF. And to do so, again, there are no libraries for .NET. So we have to do that in Java. So yes, we have a container which is running on the UpService, which is running normal ASP.NET application with the background jobs which are doing the conversion. And thanks to that, it needs custom dependencies for Java. So this is the reason why we choose that. It's like something like alien there, because otherwise everything is serverless with API for the vessels. But this one is really like from the side. And maybe in the future we will replace this one with Azure Functions with custom worker. So probably we will be able to introduce our own dependencies without really having UpService for containers. Or second thing is that we can end up with it's called container apps, which is new stuff of combining Docker and serverless on the Azure. But Azure Functions, my favorite. Actually, I love it. If you ever read the book from Sam Newman, that he says that whenever you are thinking about jumping into the microservices, maybe you can do one smaller step, which is to create just a few functions that talk to each other, separate the stuff, separate the context boundaries, and later on, when you decide you need something more powerful, something more bigger, you will move away from functions as a service to some, I don't know, for God's sake, Kubernetes or something like that. But what I really like about Azure Functions is actually like functional programming in cloud. First of all, it's incredible pricing. I like it because it can be really cheap. You have, I think, 1 million invocation per month for free, so you can play with it quite a lot. But what is really important, it allows you to do, let's say, event-driven stuff. For example, when new file appears, new forecast is calculated, or we get a new HTTP request, or something's happening on the queue. Various triggers can be used in a way that you really compose your code as a composition of functions, and it's pretty cool. Also, it has amazing scaling possibilities, and I will get to it later that sometimes it scales so well that you need to slow it down a little bit. What is really cool, it is a built-in retries. So whenever you are dealing with some with some kind of error, it will try to help you with trying at least 5 times if you don't say else. And so you don't have to think about it. Um, Let me warn you a little bit about the hosts which are hosting the Azure Function processes. I use Azure Functions for more of projects, not only for weather service. And I realized that for some kind of like calculations and doing some I/O stuff, it's not really good because those hosts, especially on the consumption plan, which is the plan which makes it nice because you only pay for what you use, they are really weak. So beware whenever you need something more powerful, you either have to switch from the consumption plan to the prepaid one, where you probably end up, you lose on all the benefits of serverless, or most of those, or you need to switch to different service. So you just need to think about it. And second thing is there are cold starts. Microsoft is doing their own stuff to make it better. It's not a big deal for background stuff because I don't care if it takes 2, 3, or 5 seconds if it's running on a background. But I also tried, and it was the initial version, we tried to also the API that is using by vessels to get the forecast to be serverless, which led to the fact that first time vessel asked, it took 3, 5, 12 seconds to wake up the instance. It was really terrible experience, not only for the vessel, for the fuel pilot, but also for us because it was inconsistent. So just be aware of it. Here's one hint from me. I don't know if you know it, but you can treat the Azure Functions that host sort of like the ASP.NET host, so you can inject your dependencies and use them later. If you use the isolated process functions, that code looks slightly different, but the logic still applies, where first of all, you register the dependencies in the startup, and then you wrap your functions into the class and get the dependencies injected over constructor. This was pretty handy for us to realize, because I was thinking, whenever I invoke the functions, I need to do all the stuff like getting, from the configuration, stuff like that. So you can slightly introduce something like state into the stateless, but be aware of it. But this is at least for the dependencies, is pretty handy stuff. I was talking about that also, the retries, great stuff. If you don't use any of those attributes, you just leave it as it is, it's okay. And as far as I know, Azure Function will try to re-invoke itself 5 times, and when it fails, it just fails. But if you want to tweak it, you can say how many retries it should try, or for example, that's like, what's the delay? Do it 5 times with 15 seconds between each. Or if you want to make it even more powerful from the stuff you, I would say, already know from libraries like Poly, you just do the exponential backup, so it starts with 3 seconds and then goes up to the 15 seconds waiting time, 5 times at most, and then it's just gone. So this is pretty cool to tweak a little bit when you know that for example, your Azure Functions will calling another stuff somewhere else, and it can fail. To make things a little bit harder about Azure Functions in these days, is there are actually like 2 way of running Azure Functions. First thing is that there's old one, which is called in process, and there's the future of the Azure Functions, which is called the isolated process. And to slightly explain how they differ, for the isolated one, instead of building .NET library that's loaded in the Azure host, you just build a .NET console application, and that references a worker SDK, so you have full control over the application startup, dependency, and stuff like that. If I would start right now, I would jump in directly into the isolated process, because in the long term, I think in .NET 8, by the official roadmap, the in-process way of running Azure Functions will be deprecated or not recommended to do so. Unfortunately, all of our services or functions on weather service are in process, so we need to fix that. But just for you to know, if you will start with Azure Function, just jump into the isolated process right away. All right, so we have an application, background jobs, everything is perfect, and now is the time to think about how to really scale. And again, here are some pain points, and I need to admit, we didn't know our enemy well. So for you, one hint, like to properly scale, you need to know who you are dealing with. You need to understand where are the expected peaks. For example, you need to know at what time of the day the forecast providers updates recalculated forecast. So you know where to expect the peaks. You know that 4 times a day, this model is recalculated by this provider and is happening at 12 o'clock. So you need to know really what are you dealing with, understand the docs, read in the docs, and really like this is the stuff I would I underestimated. However, one also interesting stuff is that when you think about the peaks, there are background peaks, which are caused by the providers, and there are API peaks. For example, when the vessel starts sailing and start asking for the data, that's the API peak you need to handle. But on the background, there can be nothing happening because you have all the forecasts already stored, so you don't care. It's just on the background. It looks nice and smooth and steady. But on the API, it's really big mess. So be aware that background peaks and the API peaks, they are not like one by one. It's not the same stuff. One of the things that worked well, and I like to share with you because it's not so common, or at least in the previous application I've been working on, it wasn't so common scale metrics, was the scaling based on the service bus message count. As I said, because of those stuff we need to do with NetCDF files, we have a background service that's doing so. And we set on up service scale setting, which you just go onto the portal, click it there, that we will scale it horizontally based on the amount of the message waiting in the queue. So if there are too many messages waiting, it just try to adding more and more and more, so it scales well, and it works really nice. It's really powerful, really easy to set up. I really recommend to have a look at this setup in the Azure, because it helped us a lot to split it and to parse the NetCDF files, and when the files are parsed, it just goes down. It's also cost effective, and also later on when you get to the overview of scale history, you see where are your peaks, which is again really handy information in the long term. For the API, as I said, it's not the same. We did the scaling based on the CPU usage. This is, I would say, more common scenario where based on the load, you will just adding more and more APIs. So again, it's really, I would say, identical or nearly similar to the way how we did it for the background services, but just a different metric. So pretty nice stuff. One thing that we learned, and I didn't know about that, is that you can also control the scaling for Azure Functions based on the trigger type, that you can tweak host JSON file to, for example, don't allow Azure Functions to scale too much. Because as I said, they're amazing with the scaling. They can scale, I would say, by definition, almost in endlessly. But don't forget that if, for example, you are using functions to write data into the Cosmos DB, you need to choke it a little bit, or we had to, otherwise you will end up in one of the famous error from Cosmos DB, which is too many requests, 429 errors, where your request units you are paying for are lower than the amount of the data you are just choking in. So you need to slow down functions a little bit. So for example, here in this case that we have a service bus that's sending messages to this function that is storing the data into the database, and we said whatever is in the queue, no problem with that. You will just have maximum concurrent calls of 8, and do your job. And so we are able to, I would say, save some money on the request units on the Cosmos DB. And also, it doesn't really matter if you will store your forecast 2, 5, 10 minutes later, because even those forecast providers, they say, oh, we recalculate our weather every day at 12 o'clock. They don't. Like, sometimes it's 11:30, sometimes it's 12:35. So if you wait 5 minutes for the queue to be handled by 8 functions and save some money, you're good. So look at this host.json. It's powerful concept how to scale also on or tweak scaling for Azure Functions. And the last thing, I'm going back to the Cosmos DB, is that you can set up the maximum amount of the request units on the Cosmos itself, so it will somehow scale from 10% to 100 based on the load. So it's nice, but again, big warning here. As I said, the Cosmos DB can be really, really expensive, and it was a different project, but I need to share it. Once I forget the instance of Cosmos DB running, it's been running for 3 months, and it costs €2,000 per month. Luckily, nobody realized, nobody knew, so I just silently deleted and pretend it never exists. But really, be careful with Cosmos DB scaling, because if you just set it 10,000 request units, be sure that you will hit it pretty fast and you will pay for it. But otherwise, the scaling capability of Azure Cosmos DB is amazing. All right. No matter how you do your scaling, no matter how you write your software, there are always some kind of errors, right? So I like to show you how we approached error handling and how we decided to don't be, let's say, zealots about functional approach to error handling. Actually, I took this approach and extracted to different talk I will point out later. First of all, in your application, we do the normal stuff like you would normally do, is like set up the union type, set up the well-structured errors in specific type, and later you will wrap them into the exception, which works like a wrapper, like a transfer layer, and you set up custom functions for throwing these errors inside. It's like combining results with exceptions, which sounds strange. I understand that. But it's really beneficial for us. First of all, we can do it on the I/O layer, on the task, on the top layer, which is impure by definition. Otherwise, it has no sense if you don't have impure layer on the top. You can really like follow simple rules. First one is that whenever you throw an exception, you do it using those custom functions I was showing you, like of empty list, of result, of option. And second thing is that the exception should always contain this kind of error, and it always should only come from the impure level. So it will let you, and it will let you new people joining your team to, I call it escape the monad. Finally, I said the monad. Yeah, escape it, and you just keep the pure flow without really like binding task results with the async results and task results options. If you ever work with results in F#, it's always good. I love it. It's amazing until you get to the async stuff. Then it's getting a little bit uglier. And another thing is that it plays well with the rest of the ecosystem. So if I want to see all the errors in some log, I don't have to extract them from the result type. So as I said, for this, I have a lightning talk, which is sort of heretical one about defending the exceptions and get rid of the results in the way we are used to do so. So just click on it. It's 15 minutes, so it's not so long. So I think you will survive. All right. Most likely, the last thing when you have everything together is to monitor what's going on. I need to share this one was rather with no problem at all. I know there are more possibilities in Azure. There's like, I don't know, open trace, stuff like that, or open telemetry. We took what's in there by default, which is application insights. I can highly recommend it. It's good. You will see your application logs, application map. You will see the errors. What is also important, you will have the correlation ID across all the calls. So if I see the Azure function is calling the Cosmos, which is doing something, I see all the flow of the program. So it's one-click configuration. We have alerts based on this. Only thing that, again, like be aware, and this is the stuff that I should know, is watch out for data retention and sampling and the ingestion. Those are three things that you can tweak in the configuration of this. And of course, everyone say, oh, you need to log everything, just put it in the application insights. Then you get the bill and say, okay, maybe we don't need to log everything. So just watch out for this. Be smart, be sensible about the logging. But otherwise, if you start with the application insights, I can like highly recommend it. It's good. But again, like everything in the cloud, it can become expensive, sort of, if you do it wrong. Okay, and this is what I call, the last thing is the boring stuff. I just wanted to know that it works if you will write your own weather service. It just works, and there's no problem with it. Service bus, just a bus. What should I said about it? It works great. App service with Giraffe, really recommend for you to have a look at Giraffe, because it's a nice way how you will jump into the functional paradigm. How will you write something which is like functional and make it more sexy? It's really good. And for all the authentication stuff, we used Azure AD, which is, again, it's there, it works. So it really, like, for you to know, to get full picture of what we used and what worked for us really well. And the last thing is the fun stuff. And this is what we call weather service UI, because we are nearly at the end. We have everything set up. And after, I don't know, 1.5 years, I think it was last autumn, product owner said, hey, look, you did good. I like it, what you did, but I need some kind of visual check what's going on in the weather service. I need to know what's going on. And we said, okay, so why not use something we already know, which is F# again. So we created a project which is called Weather Service UI, when you can have, I don't know, dashboards and drag and drop, set up the priority of the model, so you can also tweak the configuration for the weather service itself. You can see the coverage. What we did, we used React.js as a view engine. Stena, luckily, they had own React components that we just took and just bind it in the F#, which was really easy, just like one-liner, and you can start using components which already exist. And what's important is whenever you are writing something which needs domain understanding, which I would say it's any kind of serious software, is if you split teams, you just lost this kind of information, you just lost this knowledge. So we decided we will go into, which is called like full stack, which means that one team who did the weather service will also do the UI. And it was sort of risk for the beginning, but we realized that we developed the stuff in like just on 7 sprints. So it was so fast, so effective, and we were not front-end people. It was the fact that you can just plug things together in a functional way. It was so cool, and I really, if you're thinking about maybe I should give a Sharp a chance, but I'm not sure I like more front-end stuff, I definitely recommend you to have a look at the Fable compiler, which is nearly like close to version 4. And in version 4, by the way, it will be able to compile also Python and Rust and Dart and PHP and JSX, everything from F#. It works as a .NET tool. You just download it as a .NET tool and say, hey, this is my F# file, and I want to output it as a JavaScript file, and that's it. I would say that Fable is the best thing that happened to F# since F# itself. It's on the fable.io. Have a look. And if you want to start with the full stack, really, as I said, like you already having backend, you just want to add some nice UI over it, I definitely recommend you to not start from scratch. Take the template which is already there. It has been there for years, and it's really evaluated for like we love them. Whole community loves SafeStack. go to this address. There's a command to install this .NET template, and you can start right away. It uses normally React on the background, but you will not even realize. You will just write nice full stack application with the combining backend and front end stuff. And for example, if you like Blazor and you heard a lot of things about, oh, like Blazor, this is the same, but big but is that you can reuse what already exists. There are millions of components of React. There are millions of developers who are writing cool stuff in React. So we just took it like we did with the Stena components, use it, and creating something which maybe I have like 3 minutes. I can show you. Can you see it? Perfect. So this is it. And for example, I can here to see, oh, here are my vessels. I don't know, am I connected? Yes. So you see, here's a Stena Britannica. It will take some time. I don't know about the connection here, but it should show you the map. It should show you also the forecast data. And so here, I see, okay, here are the wind correction, current wave, and I can go down and see, oh, it's nearly done. It's sailing. It's somewhere between, what is it, Colchester? Where is it? Somewhere in England and somewhere in Denmark. And you, okay, yeah. So it's on the road. Yeah. So this was done by non-front-end people, only just by using what already exists, Stena components, adding some React, and that's it, right? So if you ever wanted to have some proof that F# works, it's this one. So this is where the story ends. Now you know all those things I wish I knew 2 years ago. You can now go create your very own weather service. You know how to model domain, how to set up the background jobs, how to scale, how to handle peaks, how to avoid the problems with serialization, how to store the data in immutable way, how to read NetCDF files. Yeah, you can do it. And how to keep error handling simple and all of those. So thanks a lot. My name is still Provazník. It's been a big honor for me to talk here. And thank you. And stay safe. Thank you.